Okay, so I'm going to make you guys some lecture videos. So this is chapter 2, and we're only going to do the first part of chapter 2 this week, and next week we'll do the second half. Okay, so here is an overview, and I also made you learning objectives which are basically your study guide. Okay, so these are all the things that we're going to talk about today. Okay, so the first thing is to remember that everything in the universe is composed of matter. And the definition of matter is anything that occupies space and has mass. Okay, so we find matter on Earth. So matter, as far as we know, we see it in 3 different physical states. Okay, so we have gas. So this is a propane tank. So the propane gas in there. We can have a liquid. So this is vinegar, so which is acetic acid. Or we also have in this picture sucrose, which is in a solid form. Okay, now these little pictures down here, I'm going to try to annotate, use my little pencil. Where's it at? Okay, so these little pictures down here, these are supposed to represent what the molecule looks like if we used a model that was beads. So in this picture, and as time goes on, the big gray ones are carbon. Okay, the little white ones are going to be hydrogen, and the big red ones will be oxygen. Okay, now I need to move to the next slide. And it doesn't want to let me do that if I have the pencil out. Okay, so, oh, come on. Okay, so now, what's chemistry? So chemistry is the study of the scientific study of matter. So basically what's what's an element? How do the elements react? What we're going to use chemistry for is to try to understand biological processes. So how do we, I know I'm messing, I'm trying to, give me a second here. I'm trying to, okay, so, well, no. Okay, so chemistry, what we're going to use it for is to understand biological processes and how they work. So in our body, everything that we do constantly, we have chemical reactions going on all the time. It's how we make energy, how we break down our food. Everything that we do is based on a chemical reaction. So biology and chemistry are really, really tightly linked together. So everything is a chemical system, right? So chemistry does all of it, right? Okay, now, all life is made up of molecules, and molecules are made up of atoms. Okay, so atoms are going to be the smallest units that retain the properties of their type of matter. So an atom is the smallest unit that we can identify as like a specific element. Okay, so atoms are really, really small. Okay, and then we start to put atoms together, and when we do that, we end up with molecules. Okay, so here's the individual atom, and then this whole thing is going to be a molecule. Okay, so I just told you, so here's propane gas. Okay, so it's got 3 carbons, so C3, and then it's got 1, 2, 3, 4, 5, 6, 7, 8, whoops, C3H8. Okay, so it's got 8 hydrogens. Okay, now all matter is composed of individual elements. So I kind of jumped the gun on that. So an element is a basic substance, okay, and it's made up of an atom, right? And then atoms can't be broken down any smaller. So one example of an element is sodium. So sodium, and you guys maybe have heard of all this before. So let me get my pencil out here. Okay, so the element can't be broken down. So sodium, the symbol for it is Na. Okay, and it's Na because it comes from the Greek, which was natrium, is what they called it. So it was originally natrium, and then they changed the name to sodium. Okay, so an element, they're found in the periodic table. We put them together, and when we put them together, we get compounds or we get molecules. Okay, and the smallest amount of an atom that you can get, or smallest amount of an element that you can get is an atom. Okay, so this is sodium, right? And sodium metal is actually highly reactive by itself, but we combine it with things, right? So we combine it with like chloride. And when we combine it with chloride or chlorine, right, that's when we get salt. Okay, so we have atoms of sodium, so we have Na, then we have atoms of chlorine, which is Cl, and when we put those two together, so the blue and the green together, okay, we end up with sodium chloride. Okay, and sodium chloride, we're going to take a solid and a gas, and we put them together and we get a solid again. And they call this a compound. Okay, now we're going to talk about the type of bond that holds these together, but we're going to do that in a couple minutes, so just hang tight. But it forms this really nice lattice structure. Very, very organized. Okay, now we are going to mention chemical reactions. Okay, so chemical reactions, one of the big principles of life as we know it in the universe is that we can't create or destroy matter. Okay, so we can't make something out of nothing, and we can't totally destroy something, but we can rearrange it. So chemical reactions can rearrange matter, but they don't create or destroy matter. Okay, now I want you to know these terms. Okay, so reactants are the things on this side of the arrow. Okay, so those are the things that are going to go into the reaction. Okay, so they're on the left side of the arrow, or like the point of the arrow is going to point to the products. Okay, so the reactants are what we're putting in, and the products are what we get out. So in this picture, this is how we make energy from sugar. So this is a molecule of glucose, and glucose has 6 carbons, 12 hydrogens, and 6 oxygens. And then we're going to add it to the oxygen. So this is what we eat. This is what we inhale. Okay, and then there's a series of chemical reactions. So this just doesn't happen in one step. There are a whole bunch of steps that have to occur. Okay, and that is going to give us products, and the products are water. Okay, so 6 molecules of water, 6 molecules of carbon dioxide, which we exhale, and then we get energy. And the energy we get, I'm just going to throw this out here. The energy we get, it's in the form of this molecule. It's called ATP. And we'll talk about that later, but I just want to kind of get you started on it. So reactants and products, and the arrow is to represent chemical reactions. Just got to clear. Sorry, you can probably hear my mouse scraping along. Clear. Okay, now, how do we organize matter? Okay, so the periodic table is lists all of the elements. Okay, so the person that started organizing them and putting them into and is given credit for the periodic table is this man. His name is Dmitri Mendeleev. Okay. So he's credited with it. It happened in like 1869. So basically, what was happening is that chemists we're finding all of these elements, right? And they're finding all of these things, and they're like, well, gosh, look at all of them. How do we organize them? How do we put them together? So he started organizing them in the periodic table of the elements, which you guys have probably seen at some point, maybe on a t-shirt or something. Okay, so here's the periodic table of the elements. And if you look at it and you think about it, you can kind of see, you can definitely see patterns. You can see how he started to organize them. So the first thing is he organized them by this number, this number at the top, which we're not to yet, but they're in order, right? So it's basically they're in order by size. These little guys down here, okay, they were found later and they fit in there, but they don't want the table to be super, like, to go out like this. So they kind of did like graphic artistic stuff and put it in there. But these are relatively new down here. If you notice, they all have some letters on it. Okay, and the letter, this is helium. Okay, so that's the symbol. And then underneath of it, the word is written out. Most of them are pretty logical, but there's some that you're like, what? Right? So like lead is PB. Okay. And you don't have to memorize these, so don't panic about that or anything. Okay. Now he has the columns organized and the rows are organized. Okay, and it's kind of separated out. Our book has done this thing, so the ones that are orange, these orange ones we're going to talk about in a minute, but these are really essential to life. We can't have living things without those molecules, or those elements, those atoms. So don't memorize. You don't have to memorize it. So don't panic about the periodic table. Okay, now on here, okay, here is a blow up of one of those little rectangles. Okay, so elements are listed in order of the atomic number. Okay, so the atomic number is the number at the top. The atomic number tells you how many protons something has, and we're going to talk about protons. So protons, electrons, and neutrons are subatomic particles. Okay, so sub means below, right? So subatomic particles are smaller than an atom. So they're what makes up an atom. Okay, so here's carbon. Okay, so carbon is C. Okay, the atomic number is 6, so it has 6 protons. Okay, and then carbon, the atomic weight of it is 12.01. We usually just say 12. Okay, so 12 is the number of protons plus the neutrons. So we're gonna get there. And here's a picture. This carbon is the graphite in the pencil. Okay, now 4 elements make up the bulk of cells, okay, of living cells. So the 4 elements, those are the ones that were in orange. So here's the orange, right? And they made this orange. So I want you to know these. So oxygen, carbon, hydrogen, and nitrogen. Those are the things they are the elements that make up most of what's in a cell and most of what's in us. Okay, I don't need you to memorize the percentages, but I want you to know oxygen, carbon, hydrogen, nitrogen. And I always put it CHO and then N will help you remember it. Okay, so like Chon. Okay, now there are 7 other elements that are required in smaller amounts. So those are calcium, phosphorus, potassium, sulfur, sodium, chlorine, and magnesium. Okay, and then there are other ones that are considered trace elements, and they're I mean, you have to have them to live, but they're required in little teeny tiny amounts. Okay, so I guess understand that there are small ones that are in a small amount, and then there are others that are considered trace. But you don't have to memorize all of these and where they fit in. Just know the concepts, the basic concepts. Okay, now at some point, we want to be able to go and we want to talk about like atoms, and we want to get things all the way up to an ecosystem. So we're going to start with like small things, and then we're going to work our way up. And this is like a question they want you to talk about in class, but maybe we could put it on a discussion board or something. But we'll come back to this, okay? So we'll come back to that. So just hang tight. I know you can't wait. All right, now, all atoms, okay, are composed of these three subatomic particles, and I want you to understand this. Okay, so there are protons, neutrons, and then electrons, which they have on the next page. Okay, so if you look at a picture of an atom, this is how we visualize it. Okay, in the middle, I'm going to change the color so maybe you can see it. In the middle, we have this thing we call the nucleus. Okay, so the nucleus is in the middle, and that's where we're going to have the protons, and that's where we're going to have the neutrons. Okay, so they're in the middle. Okay, protons are positively charged. Okay, so protons and P, that's a trick to remember it. Okay, and neutrons, they don't have a charge, so they're neutral. Okay, both of them are located in the nucleus, which I just told you. And then they're actually, the number of protons, that's the important thing. That's how we determine what an element is. Okay, so protons are how you're going to figure out what the element actually is. That's where that number at the top comes from. Okay, so nitrogen has 7 protons, has 7 neutrons, and it's going to have 7 electrons. Okay, now the number of neutrons can change, and if it changes, we call that thing an isotope, and we'll talk about those as time goes on. So isotope. Okay, now electrons are really small. Okay, so they have a negative charge. Okay, they circle or orbit, right? The nucleus, and these things we call them orbitals. Okay, so they're going around the nucleus. Okay, they have very little mass, so they're very, very small. It's hard to, you can't weigh them. Okay, now the number of electrons that we have in something determines whether it's an ion or not, and we'll talk about that. This is your introduction to it. And this determines its chemical reactivity, like can it bind with other things? Can it make a molecule or not, right? How likely is it to make a molecule? Okay, now I want to go here, right? So then if we go back to our nitrogen atom, it has 7 protons, 7 neutrons, and 7 electrons. Okay, so it's got 7 things that are positively charged, 7 things that don't have a charge, right? And 7 things that are negatively charged. So that means these like balance each other out, right? So the overall charge of nitrogen is 0. Okay, now, if we think about their mass, okay, protons have a charge, so we'll say 1. Okay, neutrons have a charge, which is 1, and electrons don't have a charge, or not charge, I'm sorry, mass. Protons have mass, neutrons have mass, and electrons don't. Okay, so each proton would be 1, each neutron would be 1. Okay, so 1 times 7, because there are 7 of them, 1 times 7, right? And nothing here. So that means that the total mass of nitrogen is 14. Okay, so if we go back, let me try to go back, which might not be pretty. If we go back to the periodic table, okay, here's nitrogen. Here's nitrogen. Okay, 7 is this number at the top, and then the number down here, which is the mass. Okay, so this is the atomic number at the top, and the mass is 14. Okay, so from this chart, you can figure out how many protons something has, how many neutrons something has, and how many electrons something has. Okay, so it's all very, very organized. And if you understand the parts, you can kind of start to put it together. All right. I am going to stop there. So these are in smaller pieces, and then I'll pick up here and start another video. Maybe I have to figure out how to stop it.